What's going on? This is SDG Physics. My name is Tosh Dalday, and I like Batman. Alright, now we're going to hit this thing with an inequality, and that one's a little bit tougher. We've got f of x is equal to the square root of x squared minus 6x plus 5. Alright, so I'm going to hit this with an inequality. I said it was tougher. Kind of. It just takes a little bit more thinking, the game to think about. Alright, I'm going to circle that on the inside because I don't have a fraction, so I don't have to worry about it being not equal to 0. But what I do have to worry about it is being equal to a negative number. So I say that x squared minus 6x plus 5 has to be bigger than or equal to 0. I just take whatever I circled inside of that square root and set him bigger or equal to 0. If I were to factor this, I would have x, and then I would say, I think that 5 and 1 works. But that would have to be a negative 1 and a negative 5, because if I want to add them, they have to be negative 6. I'm happy here. I'm happy with that. So it's saying that this times this has to be positive. This times this has to be bigger than 0. One way that I would solve this is I would kind of think of this as, remember, if I were thinking of this as an equal to sign, then what I would have is I would have x is equal to 1 and x is equal to 5. In fact, there is an equal to sign over there. This just has to be bigger than or equal to. So 1 and 5 are kind of I call those my points of interest. If I were to graph that on a number line, I would kind of think of it as 0, 1, 2, 3, 4, 5. Okay. Then what I would do is I would throw in some test points. And I always like to choose easy test points because they're easy. The points of interest would be this point right here and this point right here. Now, I'm going to test this region. Any numbers that are smaller than 1 and smaller than 5. So I'm going to test 0. And let's see if that works. Let's see if he's true. Alright. If I plug in 0 into here, so I'm going to plug it all into here. If I plug in 0 into here, I'll have a negative number. If I plug in 0 into here, I'll also have a negative number. Now a negative number times a negative number gives me a positive number, which is bigger than 0. So therefore, in this region, even though both of these terms come out negative, it gives me a true area. So I know that everything in this area is going to end up being true. If I plugged in negative 10 into here, this would give me a negative number times another negative number, giving me a positive number. That would be true. They would still, a negative times a negative is bigger than or equal to 0. Let's test the numbers out in here. And I told you that I like to choose easy numbers. Let's just choose number 2. So if I plug in 2 into here, this right here, 2 minus 1 will give me a positive number. And 2 minus 5 will give me a negative number. A positive times a negative will be a negative number, which is not true. So it would be false. Because it's false because a negative number is not bigger than or equal to 0. And I'm going to test out this region over here. I don't know, let's just choose the number 10. If I have 10, I have 10 minus 1, which is a positive number. I have 10 minus 5, which is also a positive number. A positive times a positive is a positive number. So therefore it's true in this region. So I would say that my domain is actually x such that, actually instead of doing set notation, I'm going to use interval notation for this one. It just seems like the easier way to go about it. I would say that my x is allowed to be anywhere between negative infinity and positive 1. Or 5 and infinity. So it can either be anywhere in this area over here or anywhere in this area over here. And the reason why I have brackets on those is because there's an equals to part. I should fill in these dots because there's of that equal to sign, so that way I put brackets instead of parentheses on. Shoots, bro! Up out!